Well, hi. Welcome to your first video lesson. So this might be a little weird for those of you who haven't already had me as a teacher and watched one of these videos. You'll see, like just here, you'll have the paper. I'm taking it off my document camera, so you'll just see my hands writing. So hopefully I can keep my nails and get them to grow for you, so at least you can watch the growth process. But anyway, today we're going to do section 1.2 out of your textbook. Feel free to rewind the video, pause it, whatever you need to do to be able to keep up with your notes. That would be great. Alrighty, so today we're going to talk a little bit about functions, a little bit about domain and range, and build upon what we had done a little bit in class today. Alright, and we're going to jump right into an example. We've already talked a lot about vocabulary, so I feel like we'll just interject that when we need to. Alright, so we're going to determine if each relation is a function, and then state the domain and range. Alright, so couple key vocabulary words you'll recognize from your sheet. A relation is just a set of ordered pairs. So a relation does not have to be a function. There's a lot of relations that are not functions. A function is where each number in the domain references one number in the range. So that for every number you input, you get exactly one output. Okay, the domain are your x values or your inputs, the range are your y values or your outputs. Okay, so let's start with our first note, and this is going to be in set notation. These braces are set notation. So we have a set of points, and we're going to ask you three questions. You want to know, is it a function? What's the domain? What's the range? So, to tell if something is a function, whoops, there you go. You want to look at the x values and see if each x value corresponds to exactly one y value, if each input matches just one output. So, for example, you input a 5 into your function. You let x equal 5, you get 4. Is there anywhere else where you have an x equals 5? No. Then you'll check the next point and say, is there anywhere that I input a -3, my x value is -3, my y value is... Okay, sorry about that. I'm recording these on a work day, and it seems that we need to make announcements every 30 seconds. Alright, so again, a -3 is your x value, it outputs your y value of 6. Do you have any other inputs of -3? No, we don't. So far so good. You would then test the next 2 points or 3 points or however many. So this is a function because every x value leads us to exactly one y value. So now we want to talk about what is the domain and what is the range. So the domain are the x values, the values for the function along the x-axis. We're going to put them in a set notation, and I like to order them from smallest to biggest. So I'm going to put a -3, -1, 5, and 9. Because we read from left to right, so therefore we should probably list our numbers from left to right. And my range are my y values or my outputs, and I have a 4 and a 6. Don't let it bother you that they repeat here. That's okay, because those are your y values or your outputs. Functions are determined by your inputs or your x values. So my range would be 4 and 6. And we don't list them twice. That just takes too much work, and let's face it, mathematicians by nature are pretty lazy. Alrighty, so let's try the second one. I have -3, 4, 5, -2, and 5, 0. And like I said, if you find that the video goes too quick, feel free to pause it while you're copying things down and then just unpause. Alright, and again we're going to ask ourselves the three questions. Is it a function? What's the domain? And what's the range? Excuse me. Alrighty. So go ahead and decide if you think it's a function. So check your x values. And I'm going to give you a second. Look here. This 5 outputs a -2. Then it outputs a 0. So this is not a function. However, it still has a domain and a range. So its domain would be -3, 5. And its range would be -2, 0, and 4. And while it just entered my mind, make sure that you guys are writing things in your notebooks. That's what I'm going to check each day as the fact that you've done the video lesson. So that'll be what you get graded on, is having your notes and the practice problems that you do after watching the videos. Alrighty. So let's move on to example 2. And if you don't have your graphing calculator handy, you're going to want to go ahead and grab it, because this is going to be very helpful if we can have that calculator. So determine if each equation defines y as a function of x. Lots and lots of ways you can do this. I think the easiest way for me is to go ahead and solve the equation for y, so get y by itself, and then I like to just use my graphing calculator and graph it and use something called a vertical line test, which hopefully you remember from Algebra 1. So, I'm going to just give you some steps here that I like to do. Step 1, solve the equation for y. Step 2, graph it, and apply the vertical line test. Alright, so let's say we have 2x plus y equals 6. And I want to know, is y a function of x? So, step 1, get y by itself. So hopefully you remember again from class we did a teeny bit of this. We're going to move this to the other side, and I get y is equal to a -2x plus 6. Just a quick review of graphing. Again, I could grab my graphing calculator and graph this, but because it's a linear equation, I'm just going to go ahead and graph it by hand. Remember, this number here is your y-intercept. So it intercepts the y-axis at 6, and then it has a slope of -2. So it falls 2, runs 1, falls 2, runs 1. If I get a graph, it looks something like this. So the question is it a function? So, quick review, vertical line test. You take a vertical line, you drag it across, and you make sure that that vertical line touches the graph only one time. So since that's the case, this is a function. Okie dokie. Alright, let's try the next one. Now this one I am going to go ahead and rely on the calculator a little bit. Okay, so number 2, I'm going to straighten up my paper here so I'm not all catwampus. X squared plus y squared equals 1. Alright, so I'm going to go ahead and get y squared by itself again. So this x squared moves, we would subtract x squared from both sides, and I get y squared is equal to -x squared plus 1. Now, do you remember how to get rid of the squared? So to get rid of y, to get y by himself, or to get rid of the power of 2, remember we can take its inverse function, the square root. So I get y is equal to, which is awesome, I now have it. Before I write down what's over here, I want to take you kind of off to a sidebar for a minute. So think back to Algebra 1 when you had this. And you said, you know what, I'm going to take the square root of both sides, and you got x was equal to 3. And then all of a sudden your teacher was like, nope. Because it could have been a positive or a negative. So 3 squared is 9, -3 squared is 9. So over here I want to put plus or minus the square root of -x squared plus 1. Okay? Alright, so now grab your graphing calculator. Let me get out of here. Hit your y equals. And I'm going to go ahead and type in both the functions. I've already typed them in, but let me clear them out so that you can see the keystrokes if you need to. You're going to hit second square root. Now, on the 83s and 84s, the parenthesis automatically comes up. Those of you who are using an older 83, you may have to input the parentheses. Let me see if I can get some of the glare off of this. Alright, so I'm going to type in negative x squared plus 1. And then I'm going to take the negative square root of negative x squared plus 1. Now hit your graph button. And there's my graph. Give it 1 second. So it's really a circle. Just for our purposes, I'm going to quickly sketch that over here again. So I have a circle with something like that. So my question is this a function? So if I apply the vertical line test, do you see that right here, the vertical line is touching those 2 points. So this is not, y is not a function of x. So hopefully that makes sense to you. Alrighty? Okay, moving on. Next example. Let's talk about how to evaluate a function. So evaluate each function. So remember, from Algebra 1, you had function notations, f of x. So f of x is defined as x squared minus 2x plus 7. And I'm going to ask you to evaluate it for 3 things. Sorry about that. Alright, the first one, I want you to find f of negative 5. So, all that means is anywhere you see an x, this time you're going to replace it with what the value of x is this time, which is negative 5. And now you evaluate the expression. So I get 25 plus 10 plus 7 for a total of 42. Piece of cake. Alright, now let's make it a little bit harder. Let's do f of x plus 4. So again, I'm still going to take the x values from the original function out. That's why I have my parentheses here. And anywhere there used to be an x, this time I'm going to substitute in an x plus 4. Alrighty? Now, from class, remember that this is not going to give you x squared plus 16. That's a super common mistake, so please don't fall into that trap. If you need to, you can come off here to the side and write your 2 binomials you're multiplying and apply FOIL. Or some of you I know like the box method and apply the box method. Okay, I'm a fan of FOIL, so that's the method that I'm going to employ. So I get x, so the first term, x times x is x squared. My outer, 4x. My inner, 4 times x is 4x. And my last. So when I clean all that up, I get x squared plus 8x plus 16. Alrighty. Now let's distribute this negative 2. Negative 2x. Negative 2 times 4 is negative 8 plus 7. Now at this point we're combining like terms. So I have x squared. I have a positive 8x, a negative 2x, which gives me 6x. I have a positive 16, a negative 8, and a positive 7, which gives me 15. Okay. Alright, we're good? Okay, last one. Let's do f of negative x. So again, this time you're going to go through and you're going to input a negative x everywhere. And I'm going to give you just a few minutes to try this one on your own. Alright, let's see how you did. Negative x squared becomes positive x squared plus 2x plus 7. And that would be my answer. So how'd you do? Hopefully great. Alright. So, let's talk about one more thing, and I think at that point we'll go ahead and wrap up the video. I'll let you practice a couple of problems, and then you can have the rest of the night to do all your other stuff you got going on. Alright, so the last example I wanted to talk to you about is graphing a function. And in this case, we're going to graph a line. It doesn't have to be a line again. Let's say graph each function. And I'm going to give you two functions. We're going to go ahead and graph them on the same coordinate plane. So I have f of x is equal to 2x, and I have g of x is equal to 3x minus 2. Sorry, 2x minus 3. I need to concentrate on what I'm doing and not daydream. So, lots of ways to graph a function. You can use slope and y-intercept. You can use your calculator. I'm going to go ahead and do this one with the chart that you remember from Algebra 1 and pre-algebra. So you input your domain, you output your range. I always like to pick -1, 0, 1. Okay, so I input a -1. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. Okay? Now, let's say we do the next one. Again, we're going to input in those values. Alright, so if I input a -1, 2 times -1 minus 3 is -5. 2 times 0 is 0 minus 3, -3. 2 times 1 is 2, minus 3 is -1. And now I'm going to go ahead and graph both of these lines. Oh, I guess I need to extend my graph up a little bit. Alright, so let's do -1, -2, 0, 0, 1, 2. So here's f of x. And now I'm going to graph g of x. So -1, -5, 0, -3, 1, -1. Okay? So we have two graphs. I just want you guys, little things I want you to start thinking about. Think back to Algebra 2 and look at the difference between this function and this function. And look at your graph and see if you can start to remember what the relationship is. We're going to talk about those towards the end of this chapter. I also would love you to go back to example 3 and look at that f of -x and try to do a little comparison between what the original function looked like and what the f of -x function looks like. And see if you can see any similarities, things that are different. We're going to start talking about that tomorrow. So just, take a few seconds, think about those. And I think that's where we'll leave off for tonight. So go ahead and stop the video, click on the practice problems. There'll be a couple there for you to do. Just add those right into your notes. And I will see you guys tomorrow in class. Have a great night.